So I'm here to talk to you about image recognition and how it's changing e-commerce and healthcare. So first, a little bit about myself. That's probably better, right? Okay, so who am I? I'm a software developer, that's my background. I studied at Sussex University, Computer Science and Artificial Intelligence. When I finished my degree, I went to work for a medical software company for about 9 years, and we built decision support software. So that helped clinicians and GPs basically make decisions and diagnoses based on our tech. I then went on to contract for about 5 to 6 years, and I worked in many different fields at that point: legal, charity, and startups. After that, basically what I'm doing right now is I'm the co-founder of my own business. It's called Furnishful. We're a furniture aggregator. We basically bring together products from about 40 different retailers, and we allow you to shop online for it. So you can come on board and discover furniture and homewares. So, about this talk, a little bit more about this talk. So, why e-commerce and healthcare? Well, they're both two fields that I've worked in extensively, and they touch our lives on a daily basis. Also, I think that AI, well, I know AI is currently being used in them, and I think that in the future it will be used in more increasingly. Definitions of AI, so very briefly. AI can be separated into kind of two ways of thinking. There's kind of general AI and narrow AI. General AI is the idea that a computer can be taught to learn and think like a human being. Narrow AI is the idea that basically it's focused on one particular task. AI that is limited to a set or predefined functions. So Siri, Spam, and I would argue all AI that we currently work on falls underneath that category. We haven't quite reached the dream of general AI, or nightmare, depending on your point of view. So image classification is just one aspect of artificial intelligence. It's just one area. Currently, image classification involves training neural networks against a large set of tagged images. The need to recognize and classify images are at the core of many pioneering AI tech that's out there in the space today. So autonomous vehicles, everyone's heard of those, robotics, and facial recognition. They all use artificial intelligence image classification as their basis. Now, why is image recognition so important? It's estimated that around 60% of the human brain is involved in vision. So if you think about that, and the idea that there's so many projects that work on AI, visual AI, you can see that cracking that would bring us closer to that goal of the general or the greater AI goal of, artificial intelligent robots taking over the world. E-commerce. ASOS is a great example of how image recognition is being used right now. I don't know how many people are aware of ASOS. I'm sure quite a few people are. They're a large retailer. In fact, they sponsor, I think, I saw this event, in fact. They're a large retailer of clothing. And if you go onto their app right now, you're able to take a picture of an item of clothing that you might like, use this kind of camera icon, feed in that picture, and they will return results that are similar to the outfit that you've taken a picture of. This is actually a good example because this is not from ASOS. The image that I've just taken there is actually from another retailer, and the results that ASOS has given me, I would be pretty happy with. I think they're a good match, down to the classification of a floral dress, and that's just by using the image. No text or words have been put in there. Where else is AI or image recognition or visual search being used in e-commerce? Or has been used, I should say. PartPick, they're a great example of a business that was for replacement parts. You basically go on their site, take a picture of a screw or a bit, enter that picture, and they'll give you a similar replacement part. What's really interesting about this is they were founded in 2013, and a mere 3 years later, Amazon incorporated them into their services. That kind of tells you how groundbreaking or interesting, at least, this tech is in the space. You can build something like this, a tool that's in a very limited domain, and get acquired by somebody like Amazon. That's pretty cool, I think. Where else is it being used? You may not be aware of, but there's image search in Google and Bing right now. You just go there, you go to their image tab, and you can enter an image, and it will basically search the database of Google, or should I say the index of Google images, and serve you back something similar or the same. Pinterest Lens, another visual searching tool that's available on Pinterest. What's really interesting about this is in 2017, you can see there were 250 million visual searches, and a mere year later, those searches had doubled. So it's something that's being used today, and it's obviously increasing in popularity. So next, how is visual recognition being used in healthcare? So diabetic retinopathy. I've been practicing. I'm glad I said that correctly. It'll probably be the last time I said that correctly today. It's a fast-growing cause of vision loss. It's very preventable when it's detected early, and it's basically detected by taking a picture of the back of the eye, and a specialist will look at that picture and they'll be able to diagnose, depending on that image, whether you have early signs of diabetic retinopathy. In 2016, Google decided to take this on as a challenge. They thought it was, again, a small enough domain, had enough data where they could feed all those images into their algorithms, their machine learning, deep learning algorithms and neural networks, and produce a system that would basically be able to diagnose. They did that by using 128,000 scans of the back of the eye, and they fed those in and used 12,000 images to test that. And what they found as a result was that the results from the trained algorithm were comparable to the specialists in that field. Where else has this been used? Skin cancer detection. Again, a lot of algorithms out there for diagnosing skin cancer. Stanford University worked on another deep convolutional neural network, which allowed them to train based on, again, another large amount, 1.28 million images, and then a further 129,000 images to test their trained algorithm against. And compared to, again, 21 board-certified dermatologists with biopsy-proven clinical images, they found that the results were, again, on par with the specialists. So why is this important? Why is it, sorry, next slide I'm going to show you. I'm stumbling over a little bit because there's a bit of a trigger warning in here, because the next slide may cause offense, but it shows why I think we need diversity in these kind of AI tools that are being produced right now. You might all have seen this before, but in 2015, this image was released on Twitter, and it showed how, if you can see, Google Photos has tagged correctly skyscrapers, airplanes, cars, bikes, graduation, and then these two young people were tagged incorrectly and offensively as gorillas. Now, the kind of questions that you should, this is basically image classification and recognition gone very wrong. Why did it happen? I ask myself those kind of questions, and those are the kind of questions that I think you guys should be asking yourselves as well. Is there a lack of diversity in engineers training and testing this kind of AI? Is there a lack of diversity in the training data itself, maybe? In healthcare, especially, data-fueled classifiers are used to determine high-stakes decisions. So you can see, this is, when it comes to life and death matters, it's kind of important that the data set that's trained and the people who build that tech are equally diverse as the people who are going to be using it, or it's going to be used on. When it comes to legal and social, again, life-changing implications. That leads me quite nicely onto my next slide. How do you get started? How do you start looking at AI? How do you start understanding it? If you guys are programmers out there, I don't know how many of you are, but there are loads of online open source resources that basically have the code for you already. You can start building your very simple neural networks, 74 lines of Python. A very cool book by Michael Nielsen gives you some good examples as well. And you can start training your database, understanding the basic architecture of how to produce these kind of cool algorithms. There are data, again, I think I've said this before, but it's good to stress. Right now, it takes quite a lot of data to train these neural networks. So having access to that kind of data can be time-consuming and costly. There are open source free databases out there for you to use. Minist is one of them, and ImageNet is another one of them. To note, 40 million tagged images, but the majority of those images, 45%, come from the US. So there might be an argument, again, to build maybe more diversity even in those image sets. So from different countries, for example. That way, there'll be an adequate representation, potentially, for people to train their data or train their neural networks against. How else can you get started? So if you don't know how to code, or you don't want to spend ages learning about neural networks and the basics or the basis of these kind of algorithms, you can use these online APIs. They're available. There is a small cost. You should look into it. But Microsoft, Cognitive Services, Google, all of the big software manufacturers out there have their own kind of APIs that allow you to incorporate AI directly into your projects right now. Not just vision. You've got chatbots, speech, language. If you don't know how to program, Google's even released Cloud ML, which is supposed to allow you to train a machine learning algorithm without actually knowing how to write a line of code. I've never used it, but I'd like to know if it works. It's Google, probably does. Get involved. I saw my last slide. Anyway, OpenCV, that's another open computer vision library, again, that allows you to, it just focuses on computer vision, that one, but it's open source, so it's another one for you to look into. These are the references that you cannot really read, but thank you.